Find the target, return its index, target missing, return where it should go. One tiny change to the standard library, it is standard binary. Uh, uh, One tiny change to the standard binary search handles both the cases. So let's break it down. I am Rachit Kakkad. Welcome back to the channel where we crush DSA and competitive programming questions. And our motto is one problem at a time. So if you are new to here, smash that subscribe button and hit the bell icon so you never miss a video, and drop a like to it so it's genuinely helps the channel to grow and also motivates me to create such more videos. So today we are going to solve LeetCode question 35, search insert position. So then let's deep dive into it. Given a sorted array of distinct integer and a target, return the index if the target is found. If not, then we have to return the index where it should be inserted. हमारे पास एक एरे है, उसमें हमें टारगेट दिया है, ये टारगेट हमें फाइंड करना है, और वी हैव टू फाइंड इट विद इन द order of log n time complexity. By seeing the order of log n, the must thing you which thing in your mind would be there is we should try with the binary search, because using the linear scan it would have an order of n because it depends on the number of elements. By having the log n we can have the half सर्चिंग इंडेक्स एंड करना ये है कि अगर कोई एरे दिया है तो उसमें मान लो कि एरे है 1 3 5 6 एंड उसमें टारगेट फाइंड करना है 5. We can say that there is 5 in the array. We have to return its index only. And if the target is 2, then you can see in the array there is nowhere 2. But we have to return the index. In which index, if we insert the 2, then the array should be in the sorted order only. We only have the array in the sorted order also, so we don't have to disturb the order. For example, we can say that example one, nums one is 1 3 5 and 6, and the target is 5. Here you can see that 0 1 and 2. On the second index there is 5, and so we have to return 2 because the index of the 5 is 2. So next example is 1 3 5 6, same array, and the target is 2. Here you can see the target is 2, and in the array there is no 2. Here you can see that between 1 and 3, if we insert 2, the order is still sorted. So 0 1, and here we have to insert at the first index to make the array sorted only. So we are going to return 1. The next array is same as 1 3 5 6, but the target is 7. Here you can see every element is less than 7, and 7 is the largest element for this array. So to place this, we are going to do is 0 1 2 and 3. 3 indexes are there total from starting to 0. Here we would put in the fourth index, so to keep the array sorted. Here we have to return the 4. So we either find it, or we have to find the insertion point. We have to do both in order of log n. The key, this is the standard binary search with one key observation about what happens when the target is not found. When binary search exists without finding the target, left has gone past at right, and at that point, left is sitting exactly at that position where the target would be inserted. And we need to maintain the sorted order also. You must be wondering why this guy is saying like this. Because every time we move left, we move it to mid plus 1. You have seen in the previous video about the binary search. If you haven't seen that binary search video, I will add in the I button and in the description also. You can watch it from there also. If you have not seen that video, please see that. Then you can have the clear idea of how a classic binary search works. Then you can have this easily with you. Uh, so let's continue this. Past an element that is too small. Every time we move right, we move it below an element that is too large. When they cross, left is pointing at the first element greater than the target, which is exactly the insertion index for us. So only change from standard binary search would be insert instead of returning -1 were not found. We have to return the left only. So let's work with the code. We are doing code in C++ as we are crushing it the DSA. So let's start coding. Sorry guys. This is the standard binary setup. Left is at 0 and right is at on the last index. Then classic binary search loop, and left is less than or equal to right. When we have to write the mid, mention in the comments that why we have written like this, right minus left by 2. Why not left minus right by 2? I have mentioned in the last previous video about this concept. Mention in the comments so I can have the idea that do you understand me or not. If you want it, I can make a dedicated video for this also, explaining you the whole concept for this one. So let's move ahead. Loop while the window is valid. Mid formula is calculated with the overflow and the safe formula, and writing the if condition to match the target. If the target mid is matched with the target or not. Here we are going to check for the left one and right one also. When nums is greater than the target. Sorry. Then we have to do is right is mid minus 1, and for the less than we don't write the else if because it already comes in the else part because we don't have any other conditions. Then we have to do the mid plus 1. And in the classic binary search, we are rating here return minus 1 because they in that question we are being told that if there is no index found like the target, then return minus 1. Here we are not going to return the left. Sorry, we are not going to return the right. The only difference between standard binary search is instead of returning -1, here we return the left. When the loop exists, left is the exact insertion point where we have to insert that number. So first let hit the submit button, run button, so we can have the error rectification if there is error. Now let's hit the submit button. Yes, there is no error in the test results. Here you can see that our code got accepted. So let's try run on this. For example, on the example one, we are going to try run. Array is 1356 and the target is 5. Uh, it's simple, easy. Left is at 0, right is at 3, mid is 1, nums of 1 is 3, and target is our 5, which is less than 3. So right becomes 0, left becomes 0, right? And our nums of 0 is 1, so target is 5, and we got the index of nums of 2 as nums of 2 as the target. We got the target, so we are going to return the 5. And for example, we have written the left, right, in the return. So we are going to try run on the example 2 also. Let's try run on example 2. 1356 with target 2. Left is 0, right is 3, mid is 1. Nums of 1 is 3, target is 2, which is less than 3. So right becomes 0, left becomes 0, and right 0, left 0, then mid is 0. Nums of 0 is 1. Target is 2, which is greater than 1. Left becomes 1. Left is 1, right? That is greater than 0, right? And loop exit. Return would be left, which is 1, correct. So 2 will be inserted at the index 1. So that's how this try run works. And the type complexity for this question would be order of log n, as we have done with the same as standard binary search. We have half the space iteration, every iteration space complexity is order of 1, just as constant, because there is just 2 pointers and a mid extra memory we have used. The entire trick of this problem is understanding why returning left works. When the element isn't found, When binary search ends, left is always pointing at the first element, strictly greater than the target, which is exactly where the point should be inserted. This pattern, lower bound, shows up in many harder binary problems. You can use this. So nail this, and you are already halfway to solve all of them. So that's the question. LeetCode question 35. Search, insert, position. Standard binary search. One line change at the end, but understanding why that one line works is that what it takes you to from memorizing the binary search to actually understanding it and using its application in the code. If this helped you, drop a like. It seriously means a lot for me. Subscribe so you never miss a video. I will catch up you in the next one. Till then, bye guys.